Hello. So this is a video about how we built the intelligent forensics evidence management and authorization system using Cardano blockchain and implementing um, zero knowledge proofs in the alias generation and also Cardano smart contracts for tracking the forensics chain of custody. So as you can see here, there are three main objectives for this system. So one is the case registration happening on the Cardano blockchain with its IPFS hashes. With the case is files being on IPFS and um, stored on Cardano for tamper resistance. And then the zero knowledge proof enabled alias generation. These alias IDs and are used to track the evidence packages and the relationship between the evidence packages and its original case is completely anonymized using zero knowledge proofs. And we have forensics chain of custody smart contract that is responsible for the tracking of transfer of custody of the forensic cases across forensic evidence packages across 18 different RFSL laboratories. So we can first start with case registration as that's the first process. So as explained in the previous architectural documentations, we are storing all of these data in a on the blockchain, and these are the informations that are loaded through the metadata, and then you can see it here. So this is a video of the case registration portal where you can see the PSID, your case ID, and officers' IDs and police station officers' IDs when more than one police is forensics officers are in place, and then a representation police officer. All these informations are collected and are IPFA are hashed. And we also collect the um, evidences media files from the ground. So these informations are stored on IPFS and also stamped on Cardano blockchain. You can see it here. So we got the transaction hash after submitting. Um, so takes some time to load. I also have the transaction over here. You can see the metadata with all of the IPFS hashes of the IPFS hash as well as the POSIX timestamp and all the SHA-256 hash. So now it's the next component, which is the alias ID management with zero knowledge proofs. So the zero knowledge proofs are itself um, the functionality leverages Midnight blockchain. So the zero knowledge proofs are um, generated on the Midnight network, and we use the public and private Oracle feature of Midnight, and that's where we store the relations between the case IDs and the alias IDs. As you can see here, uh, and any operation from this requires the signature of all three of the directors of the SCCC. So that's the proof server that generates the zero-knowledge proofs, and you can see the alias IDs and case IDs, alias source. These information are stored in the Moonlight's private oracle, and then on the public state we have the alias. So there is also one more video that goes into the depths of this implementation. Um, on or according to the proof according to the milestone evidences. So there will be one more video that is only focused on the zero knowledge proofs component as it's quite complex implementation. But here's a video. So you can see here we put in the proof server and the local database of the SCC's um, um, portals loading, and then you enter the evidence name, case ID, evidence type. So all these information are added, and then once you submit, a zero knowledge proof is generated through the SCC's proof server itself. Takes a little bit to generate a proof. And then once it's generated, they also have to again show that they have access to the, in case they want to like retrieve the relations later, despite having it stored on their local database. They can also download it by providing the cryptographic signature of all three directors. So we download a JSON of the secret, which is essentially the cryptographic proof that they know the information. All the cryptographic proof is generated through all these information. So that's a proof. That's the secret is generated from all this information hashed together. Um, the secret, and then when it's downloaded, it doesn't actually reveal the underlying data. It just reveals the hashed value of the underlying data, which is used as the secret. And the Cardano-based chain of custody between RFSL laboratories. So we have a smart contract that tracks all of these information. So remember the alias ID that we generated here. So this, so once the it's generated, we use this alias ID per evidence package, and that's what is the alias number over here. And then we have the current lab ID, next lab ID, previous lab ID, and the reports being stored in IPFS, and the hash is also uploaded to the smart contract. And we also get the cryptographic signature of the custodians um, that they authorize the transfer of custody of that particular evidence package. So here's the video of it. So in the chain of custody for this evidence packages portal, we have to type in the alias, the that's generated, the alias evidence package alias that's generated from the previous directory portal through zero knowledge proofs. And we have all these data displayed about the transfer of custody of these evidence packages stored on the smart contract. You can also download it as JSON. So, um, yeah, here's the list of all transactions. We have 19 transactions. Um, so one is the first initial one is the mint of the asset ID that directly relates to the alias that is generated, the public alias from the ZKP. The other 18 are the transfer of custody of the evidence packages. So when we can also view a particular transaction and look into the datum. So all of these information are stored here, which are then retrieved and displayed on the chain of custody portal. So that's a small overview about what we built. So here's also a diagram that explains the datum that we get and the process of the chain of custody tracking. So thank you.